Great. Hello everyone, how are you? My name is Prakhar Srivastav and I welcome you to these lectures on engineering mathematics for GATE examination. And so today we are going to start with a very important topic of complex numbers. But this is a wrong definition because when it comes to GATE examination, you don't have complex numbers. Instead, you have complex analysis. Okay, so the topic that we are going to cover today is complex analysis. Approximately it will take 4 to 5 lectures to completely cover this topic. And so directly starting with the topic, first I want you to understand this topic, what this topic is all about, what is the expectation from you when it comes to this topic, and why do you think that this topic was introduced in GATE syllabus, right? Okay, so we'll move forward, and first I'll give you a brief idea about certain things. See, if you belong to mechanical engineering, you might have heard of potential flow and stream flow. If you belong to electronics and telecommunication or electrical, you might have heard of electromagnetic induction. Whether you belong to any field, earlier there used to be only one number system that starts from minus infinity and continued till plus infinity. But there are n number of phenomena in this world that were not possible to explain using this number system. So there were many scientists who try to discover that what is something that is missing and which is restricting ourselves from proving the real life phenomena. See, our mathematics and science is the subset of nature. Okay, our nature is not the subset of science and mathematics. Many of you and many literate people deals with this statement that I will not be accepting or I will not be buying this statement because this is not proven by maths or science. My friend, maths and science are not even discovered completely yet. So that is why there are a lots of phenomena that is happening in the natural world that that cannot be explained with the help of science and maths, and it doesn't mean that they don't exist or they are not real. They are real. We just don't have numbers and logics to explain them. Similar thing happened in, like, you can say early 16th century, and then there was a term that came up. See, there were many phenomena in this world we were not able to explain because the result was like this, that is minus x. Now, till now we have only understood, or it was the shortcomings of our natural, like real number system, that we cannot have a negative sign under root. Have we ever heard till like 10th class? No. No, we haven't heard of it. So that is why, does it mean that it does not exist? No, it does exist. So that is why many people, while calculating a lot of things, get stuck on this number. So that is why in late 16th century, this number was converted into x into root of minus 1. And this root of minus 1 was regarded as I. Now, since this is a number system that is altogether different from the real number system we were using. So for the sake of naming it, we named it as imaginary number system. That is, many people think that if we are saying that it is an imaginary number, it does not exist, it exists in our imagination. No, this is wrong. Imaginary number is just a number. We are just naming it as imaginary because its counterpart is known as real part. That's it. But it doesn't mean that it does not exist or it is an imaginary number. No, they do exist, and it is a proof from the various, you can say, various phenomena that is occurring in the world, that yes, these number exist. That's why with the help of these numbers only we are able to explain a lot of things. I will not go deep into this because this is not a philosophy class. But yes, and my energy level will be low because I'm not feeling well, and my sound, like the voice is also will be quite, you can say, heavy. So nevertheless, so there existed a real number system, and we added an imaginary number system to it. We added an imaginary number system to it, so that now a lot of things can be explained. So if I explain it to you in terms of graph, earlier there used to be a line from just a second, from minus infinity to plus infinity, and later there was introduction of a imaginary number line, that is again from minus infinity to plus infinity. But since it is an imaginary number line, we added an I to it, and that is why our whole number system was transformed from an axis to a plane. Okay, and that is where the complexity comes in. Okay, that is where the complexity comes in. I'll tell you why. I'll just give you a small example. Just understand. If I write y is equal to 4x, this can be represented like this. This is x-axis, this is y-axis, and if y is equal to 4x, so if x is 1, y will be 4. If x is 2, y, it will go like this, right? So if you see, try to understand. If you understand at this partner, you won't be facing any difficulty, because many student finds complex number difficult because it is complex. You have to understand why it is complex, then you won't be finding it complex. Okay, so here the input value is on x-axis and the output value is on y-axis. Okay, right. So now on a plane we can represent both input and output. This is simple. But now I will say that z is equal to x plus iy. Now if I say x plus iy, it is a point here. Z is equal to x plus iy, this is a point here. So now this is x-axis and this is iy-axis, right? So using this whole plane, I am only giving input. I am only giving inputs. Try to understand. There is no place to show output here. Here, if we are using one axis for input, other axis can be used to show output, right? Second axis can be used to show output. But here both the axes are used or consumed in showing the input, because here the input is two-dimensional. Now if this is a plane, we require another plane to get the output. Like on one axis we are giving the input, we use the other axis to get the output. Similarly, if we are using one plane to give the input, we require another plane to get the output. And similarly, we have drawn another plane. So this is known as Z plane. And we have drawn another plane. This is known as W plane. Okay. And here, like y is a function of x. Similarly here, w is a function of z. Now, z in itself is a two-dimensional. That is why z is being represented on a plane. Now, for every z, for every value of z, there is a corresponding value of w. For every value of z, there is a corresponding value of w. And that is why input is given with the help of z plane and output is given with the help of w plane. Okay. For example, I will write w is equal to z square plus z. Okay. Now z is x plus iy. Simple. Z is x plus iy. Now you put different value of x and y, you will get different value of z. And if you put different value of z, you will get different value of w. What is w? W is output. And what is z? Z is input. Okay. And if you say z is input, but this is a two-dimensional input. This is a two-dimensional input. Now, if it is a two-dimensional input, we require two different planes. That is, one will be the input plane, that is the z plane. One will be the output plane, that is the w plane. One will be the input plane, that is the z plane. One will be the output plane, that is the w plane. And that is why this problem becomes complex, because we are not able to see it directly in a 2D diagram. That is why this problem came to be known as complex programs. Complex, that's it. They are complex because they cannot be visualized. They have to be visualized. They cannot be represented on a paper. That's it. But earlier, the real number system, both the output and the input can be represented on a paper. Whereas in this case, you have to imagine there is a z plane, there is a w plane, and whenever we are using the value of z plane, it is getting corresponded to a w plane value like this. Is it clear? So that is why when y imaginary number was introduced, because there were n number of problems in the real world that cannot be solved with the help of imaginary number. That is root over -1. Okay. Now root over -4 is nothing but 2 root over -1. So root over 4 into root over -1. So this is plus minus 2i. That is, it can be plus 2i, it can be minus 2i. Is it clear? This value is imaginary. We have just defined the value of root over -1 as I. That is why we are able to solve a lot of problems. Okay. So that is why it is came in, you understand. Now why it is known as complex, you also understand, because it cannot be represented on the paper. It has to be visualized. That's it. Now, since it is a new number system, you again have to start it from class 1. Okay. You again have to start it from class 1. So in class 1, what you understood, you basically, how you started with real numbers in class 1, you understood how to add these numbers, how to subtract these numbers, how to multiply these numbers, okay, how to divide these numbers, how to take power of these numbers, how to take log of these numbers, right? Right. And then in 11th and 12th, you understood how to differentiate real number functions, how to integrate real number functions, how to take the Laplace transforms of real number systems, right? So you have understood all these things for real numbers since your class 1. Okay, slowly, but we have to understand everything at once for complex number in a very simple manner. So when it comes to the GATE examination, okay, there are some basic problems. These problems are very important. Okay, it using log and power and de Moivre's theorem and all, we'll understand. And similarly, these two, three things are very important from the exam perspective. But to understand these things, you have to be thorough with this part. Okay, these part like addition, subtraction, these things will not be asked in the examination. But if you are not clear with these basics, you won't be able to move forward. So that is why we will be starting with this part, okay, in a class or a two, and the remaining major time we'll be spending on this part. So this is complex number, the basic operations on complex number, and this comes when using these complex number, we get to solve complex functions. Is it clear? So this part is known as complex functions, this part is known as complex number. Okay, so what is important from the exam perspective? This is important from the exam perspective, this is not important from the exam perspective, but if you need to understand this thing, you have to be thorough with this. That's it. I hope you are clear in these 15 minutes that what do you mean by complex. You, I'll give you 2 minutes. I'll give you 2 minutes. Please try to write whatever possible in your own language, in English, Hindi, Telugu, whichever your language you are comfortable with. Please write whatever I have told you till now, because whenever you will open up your book for revision, you will be able to relate to this topic in a better manner. See, this is not something as rocket science. It's just that we have already built a notion that there cannot be a negative number under root. We have already built a notion that the real number system only exists. Okay, so now this thing becomes difficult because we have to study, but before we study, we have to break those notions. Okay. So you write it down. That is my request. I'm giving you 2 minutes. I'll just get my water. Okay. By the time you write it. Okay. So we'll continue with the next part. So first we will start with the basics. कॉम्प्लेक्सिटी में हम थोड़ा सा जाएंगे. वील डिग डीप इनटू द कॉम्प्लेक्स प्रॉब्लम्स. So first I'll directly take you to the basics. See, this is your axis. If I have to plot a complex number z, that is 4 plus 3i. So this is known as real part. This is known as imaginary part. If I ask you what is real part of z, what you will say? If I ask you what is the imaginary part of z, what you will say? 3i? No, 3. Because I in itself, it is a notation that it is an imaginary part. But if I ask you what is the real imaginary part of this number, it is only 3. Star mark and write it down in your notebook. Now, if you need to plot it, how will you go? So this is x, this is y. Z is represented as x plus iy. So if you see, x is nothing but 4 on x and 3 on y. So if you see, this is your 4 plus 3i. Right? Right? That is, if I say this part is x and this part is y of x plus iy. Right? Right? For x plus iy, this is there. Now, very, very important part. Now, very, very important part. Let me move forward. Simple. If I ask you 4 plus 3i is added to 5 plus 9i, what you will do? The problem is very simple. You add the real to real and the imaginary to imaginary. So this becomes 9 plus 3i plus 9i is 12i. Simple. So this is how you add, this is how you subtract. This is how you add, this is how you subtract. Now, this is a very simple thing, that is added, addition and subtraction of complex number is easy. Now we'll see simple the multiplication and the division part quickly, because I don't want you to stay behind. Suppose the complex number 1 is 4 plus 3i and complex number 2 is 9 plus 2i. Now if I ask you z1 into z2, z1 into z2 is nothing but 4 plus 3i into 9 plus 2i. Now this is nothing, 4 into 9 is 36, 4 into 2i is 8i, 3i into 9 is plus 27i, 3i into 2i plus 6i square. Now you all know I is nothing but root over minus 1. So if you calculate I square, this is minus 1. So this is 36 minus 6, because I square is minus 1, plus 35i. So this becomes 30 plus 35i. Very simple, very simple thing. You directly multiply. When it comes to the matrix, the multiplication of complex number, you directly multiply and replace the required value. That's it. Okay. And now it comes to the division part. Suppose z1 is 4 plus 3i, z2 is 2 plus i. Now z1 by z2, what will be z1 by z2? 4 plus 3i divided by 2 plus i. Now can you divide it? No. So how to divide it? Now this is the fourth operation that we are learning on complex number. So how you divide it or how you solve it? You multiply it with the conjugate of denominator. Minus I, minus I. Now this is a plus b into a minus b. A plus b into a minus b is what? A square minus b square. That is 2 square minus I square. Okay, and numerator you directly multiply. 4 into 2 is 8 minus 4i plus 6i minus 3i square. 8 plus 3, because I square will become minus 1. So minus plus. This is 11. 8 plus 3 plus 2i divided by 2 minus of minus 1 is 2 plus 4 plus 1, that is 5. So if you say this is 11 by 5 plus 2 by 5i, this is your real part, this is your imaginary part. But if you are not doing this step, you won't be able to reach to this step. This step we are doing just to denominate the factor I in the denominator, just to eliminate I in the denominator. How you eliminate a complex number from the denominator? By multiplying it with its conjugate. Star mark it, pause the video, star mark it and write how you divide a complex number in this manner. How you divide a complex number in this manner. So you have understood 4 things. How to add, how to subtract, okay, how to find the product, and how to find the conjugate. Sorry, the quotient or the division part, right? Right. These things are important from the exam perspective, because if you don't know, see, directly these things will not be asked, but they will be asking you certain things like, like what? Like the functions or the conjugate part, or you can say the differentiation and the integration part, the Cauchy-Riemann integrals. But for that, you should know these steps. Okay. Now the fifth thing that I am going to teach you is conjugate. Now, if a complex number is x plus iy, its conjugate is represented by a bar on top of it, and it is nothing but the negative part of the imaginary section. The negative of imaginary section. This is nothing but conjugate. Is it clear? So please note it down. It's just a normal notation. That's it. Next thing we need to understand is very important from the exam perspective. Modulus and argument. Modulus and argument. Modulus and argument. Modulus and argument. Now, this thing is something that is going to shape your future functions. So that is why if you don't understand, pause, rewind, do ask questions. But this is very, very important for you to understand that you have to ask and you have to be attentive, right? So let's move. See, I have a complex number z, which is x plus iy. If I go and plot it on x-axis and y-axis, it will go like this. X, and suppose this is y. So your point will be here, x plus iy. Now, you try to join it from the origin. It goes like this. This is nothing but x, y, and this is nothing but x. Okay. Now suppose I am calling it as r. Suppose I call it as r, and suppose this angle is known as theta. We don't know r, we don't know theta. But can you write x is nothing but r cos theta? Resolving in mutually perpendicular directions. And y is nothing but r sin theta. X is nothing but r cos theta, y is nothing but r sin theta. So this is nothing but r cos theta plus I into r sin theta. Can this be written as r? Please be careful. Cos theta plus I sin theta. Yes or no? R, this can be written as e to the power I theta. So z can be represented as r into e to the power I theta, where r is nothing but the value. अब r को क्या बोलेंगे? What r will be called as? What r will be denoted as? R is nothing but called as modulus, and r will be nothing but root over x square plus y square, right? And what do you mean by theta? Theta is nothing but argument, and this is nothing but tan inverse y by x. Why? Because if you see tan theta will be what? Y by x. So theta is what? Tan inverse y by x. So what do you mean by theta? Theta is known as argument of a complex number. Theta is known as argument of a complex number. R is known as modulus of a complex number. R is known as modulus of a complex number. Okay. So if you call R is nothing but it is represented as this. It is represented as this, or it is equal to nothing but x square plus y square. Similarly, if you talk about theta, it is represented as argument of z. Okay, or it is also known as amplitude of z. Okay, and it is nothing but tan inverse y by x. That is the imaginary part by the real part. Is it clear? This is nothing but known as modulus. And this is nothing but known as argument. Argument tells us at what angle the line between the complex number and the origin is working with the x-axis, and r is nothing but it is the length of the line joining origin and the complex number. Is it clear? Is it clear? So that is why now you have understood about how to add, subtract, multiply, divide complex number. What do you mean by conjugate of a complex number? And you are also understood what do you mean by modulus and argument of a complex number. Please note it down in your own language. down. Now there are certain properties that you need to understand. I'll go to back to the conjugate part. One very important property is this, that is, if you multiply the complex number and its conjugate, it is nothing but the square of the modulus. The square of the modulus. Z into Z bar is nothing but square of the modulus. Is it clear? This is the only important property, otherwise all the properties will be clearly visible. Okay. Chalo, let us solve a problem. Let us solve a problem. Argument of Z plus 1 is pi by 6. Argument of Z plus 1 is pi by 6. And argument of Z minus 1 is 2 pi by 3. Argument of Z minus 1 is pi by 3. Find Z. Try to solve it up. Try to solve it up. This is an easy question. This is an easy question. Try, I'll be back in a minute. Fuck. Okay, so this is a simple problem. We'll directly approach it in the manner, the help of formula. Argument of z plus 1. Suppose let z is equal to x plus iy. Okay, so argument of z plus 1 is nothing but argument of x plus 1 plus iy, because z plus 1, this real part will get added to the real part of z. Okay, so this is nothing but tan inverse y by x plus 1. Okay, and it is nothing but equal to pi by 6. Okay, y upon x plus 1 is tan of pi by 6, that is 1 by root. Okay, so this is equation number 1. Equation number 1. Similarly, if you solve this, this is nothing but tan inverse of y upon x minus 1. This is nothing but 2 pi by 3. So y upon x minus 1 is tan of 2 pi by 3. Or this is nothing but y upon x minus 1. What do you mean by tan 2 pi by 3? What do you mean by tan 2 pi by 3 is 120 degree. 120 degree is what? 90 plus 30 degree. So this will be in the second column. This will be in the second column. Right? This will be in the second column. Now this is equation 2. We have two equations. We have two equations and two variables. If you solve them up, I'll directly write it, because दो equation है, you have two variables. Simple solution is required. 1 by 2 plus root 3 by 2i. Z is nothing but 1 by 2 plus root 3 by 2i. Now this is a simple problem using the simple formula that I have taught you. Okay, so I don't think this is a big game. Now let us move to the next topic, that is nothing but our very own there are properties that you need to write. Now one property says that if you add two numbers and take the modulus will be almost less than or equal to the individual modulus. This is just a property. That is, if you add two numbers, the modulus will always be lesser than this. And if you subtract two numbers, the modulus is always greater than the individual modulus. Okay, so these are the two properties that you need to write in your notebook. These are the two properties that you need to write in your notebook. I'm not going to give you the proof of them because it is not required. Okay, the third property is amplitude of Z1 into Z2 is nothing but equal to amplitude of Z1 plus amplitude of Z2. Yeah, argument of Z1 plus argument of Z2. So this is first property, this is second, this is a third and a very important property. If you take the amplitude of two numbers, two complex number together in a multiplication form, it is nothing but amplitude of first complex number plus amplitude of second complex number. Similarly, if you take the division, I'll but obvious mention this as well. Amplitude of Z1 by Z2 is nothing but amplitude of Z1 minus amplitude of Z2. So these are the basic properties that I want you to note down. Because we haven't started with the main part, today I want to cover the important part only. Now, a very important theorem, De Moivre's theorem. This is a very, very important theorem. Suppose you want to take the power of a complex number. Suppose you want to take the power of a complex number. Please understand, this is very important. Now, suppose z is x plus iy. Z can be written as r cos theta plus I sin theta. Right? Right? These are the two forms. These are the two forms. This is a Cartesian form. This is a Cartesian form. This is known as Cartesian form. Cartesian form. So a complex number can be written in multiple ways. These are the two ways. Okay, now if I say z to the power n, it can be written as r to the power n cos theta plus I sin theta to the power n. Now, according to De Moivre's theorem, this can be written as to the power n, na? So cos n theta plus I sin n theta. That is the n that was there in power came down. The n that was there in power came down. Okay? Please note it down. Please note it down. This is how you solve a problem when complex number will be having powers. Okay, you don't have to multiply them again and again and again and again. You can use De Moivre's theorem to solve the problem. You can use the De Moivre's theorem to solve the problem. I'll give you an example. Chalo. Cos 3 theta plus I sin 3 theta to the power 4 e to the power I into 3 theta. सही लिखो, गड़बड़ हो जाएगा नहीं तो. Cos 3 theta plus I sin 3 theta to the power 4 cos 4 theta minus I sin 4 theta to the power 3 to the power 5 divided by cos 4 theta plus I sin 4 theta to the power 3 cos 5 theta minus I sin 5 theta to the power 4. What is the value of this? तो ऐसा कर लो, प्लस और ये माइनस. Now solve this problem. Solve this problem. De Moivre's theorem is a really, really important problem. Like theorem. Solve it up. See, this is a quite easy problem. If you solve this, this will become cos 12 theta plus I sine 12 theta because of De Moivre's theorem. This will become cos of 20 theta minus I sine 20 theta, that is 5 came in, divided by simple cos 12 theta plus I sine 12 theta, and here cos of minus 20 theta minus I sine 20 theta. Now if you see, this and this will get cancelled. Here also minus and minus, cos, the minus sign within cos will become positive itself. This and this will go off, and the answer comes out to be 1. So this is the power of De Moivre's theorem. This is the power of De Moivre's theorem. This is the power of De Moivre's. Okay, I hope that this is crystal clear to you. And here we complete the basic thing that is required from the exam perspective. Okay, that is the simple thing, quite simple thing. Okay, now from the next lecture, we'll move our focus to the roots of complex number, that is the cube root, the square root of a complex number, the cube root of a complex number. Okay, what is the power, nth power, like 1 by nth power of sine theta. Okay, like the different expansions. And from the third lecture, we'll start with and from the third lecture, we will be starting with our very basic thing, very basic thing, that is the complex functions. Okay, so I think that I'm done for the day. Thank you guys for watching the video. I'm not feeling well, so I'll not be continuing. Otherwise, I would have like completed this part. But yes, I think that it is done. And I would like to tell you this one thing, very important, that in mathematics, you have to make the strategies different for different subjects. Like if you talk about the linear algebra, it is purely based on practice. If you talk about the calculus, the integration part, it is purely based on the ability to recall and apply a particular format, because there is no fixed format in integration. You have to practice so much that whenever you get a question, you get an opportunity to apply your brain. And if you think that on the spot I'll apply my brain, you won't, sorry my friend, it won't be possible, because the more you practice, the more your brain give a click that yes, you have to use this thing, you have to reduce this whole big question into a smaller form using this thing or this replacement or that replacement. Like this is how the problem goes with the integration part. When it comes to the complex number, the most important thing is that you understand what is the requirement of why it is included in your syllabus. Because complex number, see, they don't expect you to be very much like, you can say, you should be having the PhD degree in complex number. No, they just expect you, the examiners just expect you to have a basic understanding, and that to a very thorough understanding when it comes to complex number. It should not be vague understanding. Many people, most of the teachers focuses on how to solve questions of complex number. I can teach you that in one day. But what I want to teach you is that you should get connected to this topic, because there are few people amongst you only who are going to actually, you can say, actually going to do research on complex number in upcoming days. You are the people who are going to actually make India proud, like one day, in the field of mathematics. So I want your roots to be very strong. I know these are the lecture for your GATE examination. You might be investing very less time, but yes, whatever time you're investing, I want that time to be effective. When it comes to probability and statistics, it is an easy thing, but yes, it is a highly in demand subject, and I want you to be very much careful when I'm teaching probability and statistics, because you might have heard of the terms like data analysis, the complex the data analysis and the machine learning and the artificial intelligence. It is nothing but probability and statistics. That's it. We summarize the data using statistics and use that summary to predict the future using probability, and that is very important. If you try to skip these things just for the sake, you're going to only get 1 or 2 questions. Sorry, these things are scoring. Okay, and mathematics is like 15 out of 15 you have to score. You don't have room even for a single mark here. The questions are easy, the questions are direct. and I have an experience of teaching about like for about 6 years now. And in these 6 years, 6 paper happened. My preparation of 3 years, 9 papers total. I have seen 9 papers. Out of these 9 papers, there was not even a single question that I was not able to solve. Okay, in these 9 years, I was able to solve every single question from mathematics. This is not because I'm smart. This is because I have practiced and I have taken mathematics seriously. Mathematics is easy. Mathematics is entertainment. Mathematics is predictable. So that is why you have to focus on mathematics a lot. Okay. So I think that I'm done for the day. Thank you guys for watching the video. Hope you have enjoyed. And yes, in the next lecture, we will be starting with the roots and then we'll be moving to the complex functions. Thank you and all the best.